Hello students. Um, Today we'll be discussing about 7.08 nuclear energy. Okay, let's start. The nuclear power station on the right can generate enough power to supply a large city. Like most power station, it uses to heat to make steam to drive the turbines which turn the generator, but the heat doesn't come from the burning coal, gas or oil. It comes from the uranium atoms as their nuclear decay break up in a nuclear reactor. That means we use nuclear energy to supply electricity in large cities. Most power station uses these energy also in generators, and this energy doesn't come from the burning coal or the gas. It comes from the uranium atoms that goes through a nuclear decay, that is the breakup. Okay, that means the breaking up of the nuclear releases this nuclear energy. Radioactive decay is usually a slow process. However, with some nuclei, much faster decay can happen if the nuclei are made more unstable by bombarding them with neutrons. That is what happens in a reactor. If a particle penetrates a charged nucleus, this is called a nuclear reaction. Okay, so we know the more unstable the nuclei is, the more faster it decays. So this is made by bombarding extra neutron, and when this is what happens in a reactor. If a particle penetrates and changes a nucleus, this is known as nuclear reaction. That means when you are bombarding a neutron in the nuclei, the mass number changes and it makes it more unstable, which lets the nuclei to have more faster decay, and this is known as the nuclear reaction. Okay, now nuclear fission is the splitting up of the nuclei. Natural uranium is a dense radioactive material. It is mostly made up of two isotopes, that is uranium 238 over 99% and uranium 235 with less than 1%. On the right, you can see what happens when a neutron strikes and penetrates the nucleus of uranium 235. The nucleus becomes highly unstable and splits into two lighter nuclei, shooting out 2 or 3 neutrons as it does so. The splitting is called fission. As I have told you earlier, it releases energy which throws the bits apart. So this is a nuclear reaction, that is a chain reaction that is actually taking place. Neutron is bombarded and this makes it unstable, and they are forming two of the nuclei, daughter nuclei, and these two are also forming these three, and this way the chain reaction goes on. Okay, now the energy release. In a chemical change such as burning, atoms get rearranged. Energy is released as electrons settle into different position in atoms. In radioactive decay, nuclear particle gets rearranged. The energy released per atom is around 1,000,000 times greater than that of a chemical change as burning. In fission, it is different, that is lot more atoms are involved every second than in natural decay. That's why energy released much more rapidly. That means comparing these three, in fission more amount of energy can be obtained. That is, in a chemical change, burning atoms get rearranged, energy is released in electrons settle into different position of the atoms. But in fission, lot more energy involved every second than in natural decay. That means that is the reason why we get large amount of or more amount of energy from fission. Okay, so this is a way of chain reaction, that is if the neutrons go on to split another nuclei and so on, the result is a chain reaction. Okay, as above, this releases energy very rapidly. The new nuclei bump into the other atoms and make them move faster. In this way, nuclear energy is changed into heat. Okay, so this nuclear energy is changed back into heat and if the chain reaction is uncontrolled, the heat builds up so rapidly that the material bursts apart in an explosion. Okay, if the chain reaction becomes uncontrolled, the nuclear explosion occurs. That means the heat gets builds up, and this creates a pressure which bursts apart in an explosion. This happen in a nuclear bomb. If the chain reaction is controlled, there is a steady output of heat. This happens in a nuclear reactor. So in a nuclear reactor, the chain reaction is controlled, but in a nuclear bomb it is uncontrolled, which can cause huge amount of explosion. Okay, this is fission in a reactor. Most reactors use uranium dioxide as their fuel. The fuel is in the sealed cans or tubes. The natural uranium is enriched with extra uranium 235. To keep the chain reaction going, the neutrons have to be slowed down. Otherwise, most get absorbed by uranium 238. A material called moderator is needed for this. So what is the function of a moderator? Moderator is there to slow down the neutrons. That is, to keep the chain reaction going, the neutrons have to be slowed down. That means a moderator is used to slow the neutrons, or if it doesn't, it will be otherwise most get absorbed by the uranium 238. Okay, then graphite is used in some reactors, waters and others. The rate of the reaction is controlled by raising the control rods. That means there are also control rods, that is, you can see here the control rods. These are the control rods that controls the chain reaction, okay, by lowering. That means graphite is used as some reactors. Then a reactor can blow up like a nuclear bomb. The atoms of uranium 235 are too spread out for an uncontrolled chain reaction to happen. Okay, nuclear waste. Now we'll discuss about the nuclear waste. That is, after a fuel has been a reactor for 3 or 4 years, it must be removed. That means and replaced. The amount of uranium 235 has it fallen and radioactive products are building up. Some are very dangerous. For example, strontium 90 and iodine 131 are easily absorbed by the body. Strontium becomes concentrated in the bones and iodine in the thyroid gland. Plutonium 239 can be used as a nuclear fuel, and in nuclear weapons it is highly toxic. Breath in and as dust and the smallest amount can kill. Okay, so nuclear wastes are very harmful. So they have to be dealt with very careful way. That is, if strontium 90 and iodine 131, strontium 90 causes damage in the bones, where iodine 131 causes damage in the thyroid gland. And plutonium 239 it is inhaled like dust, and smallest amount of it can kill a person. Okay, so we must have to be very careful using the nuclear waste. Now, waste from the nuclear reactor is taken to a reprocessing plant. That is, their unused fuel and plutonium will be removed. The remaining waste will be stored with thick shielding around it. Some of its isotopes have long half-lives, so safe storage will be needed for thousands of years. Okay, the remaining waste will be stored with a thick shielding around it. As I have told you, that is, the container must have a thick shielding, so that some of the isotopes have long half-lives, so these will safe storage will be needed for thousands of years, and these will not let the nuclear waste come out. Okay, this is a nuclear reactor. You can see this is a nuclear reactor, and these are the control rods, the steel vessel pressure, hot water, cool water. Okay, nuclear fuel in the code. These are nuclear fuel. The pressurized water in the reactor PWR uses water as its moderator. Okay, So moderator slow down the neutrons, and in this case water is used as moderator. The water also carries some heat away to the boiler to produce steam for the turbines. That means the heat energy is used for the turbines to rotate. Okay, so I guess I hope you are clear with the lecture. If you have any problem regarding the topic, please let me know in the comment section. Okay, I hope you have understand it clearly. Stay safe.